Good afternoon. Thanks for joining the webinar. My name is Jacob Powell. I'm a General Agricultural Extension faculty with Oregon State University Extension, based in Sherman and Wasco counties. I primarily assist dryland wheat producers in north central Oregon. Recently, I had several producers who are becoming more interested in using some of these biological products to improve wheat production. As a result, I started doing some research trials this past year with funding from the Oregon Wheat Commission. And my hope this afternoon is to share with you the results from some of those trials, information I've heard from others trying out some of these biological products, and to hopefully provide you with some management decisions on if and when you should possibly consider about using these biological products. So an overview for this afternoon, basically going to provide some context on what are biological fertilizers, are also referred to as biofertilizers, summarize research trials in spring wheat in both Morrow and Pendleton, and then we'll discuss some research trials that I completed in Morrow and Duford, Sherman and Wasco counties. I'll also be referring to a few other research trials that others have also been doing in the region, and wrap up with a conclusion. Like I said, hopefully address most of those questions you guys might have at the end of it. So to begin with, biofertilizers, it kind of seems like a mouthful of a word. And basically, it's just ideas that you have a biological product or bug in a jug, as we used to say with some of these products, that you're purposely applying bacteria and fungi to the crop with the intention of enhancing nutrient uptake, stimulating natural processes such as nitrogen fixation, reduce plant stress, and possibly improve crop quality and yield. So I have a picture of corn up here because a lot of these biological products were initially developed for corn in the Midwest. And there's hundreds of these products on the market now, Pivot Bio being a classic one. That was one of the first products that came on the market for corn producers to use in the Midwest. So my goal as kind of the extension agent here is trying to ground truth some of these products that we have hundreds of these products on the market. A lot of them are coming out here from the Midwest, where growing conditions are very different than here in north central Oregon, where we have a lot more drier conditions. And in addition, most of our precipitation is happening in the dormant season of the year and over the winter time, versus where a lot of these products are used in environments in the Midwest, where they get a lot more precipitation during the actual growing season. So that's one thing that, we have a lot less precipitation and rainfall when we're actually trying to use these products. So that could create some barriers potentially. So this slide here is just highlighting that, again, a lot of these biological products first came out with corn. And I would say that, the research is showing that a lot of these products work great on corn, not as much as research is being done on wheat, though, unfortunately. But so just to summarize, there was a very large study in Brazil that was done across 103 different field trials across 54 states here in the country of Brazil. And you can see the effect of inoculation percent. Basically, this table here with the different maize attributes is just showing that. So they applied these products. What was the effect of inoculating the seed with these biological products based by different attributes of the crop? So grain yield, for example, grain yield was improved about 5.4% by using this amount of nitrogen and leaf-in nitrogen in the leaf tissues, grain nitrogen in actual grain itself, and root mass. And so you can see this product, for example, seems like it had a very big effect on increasing root mass, maybe a little bit less so on grain yield. And so overall, the study demonstrated that, they reduced their fertilizer rates in these trials. And so because of reducing that fertilizer rate and applying this biological product, they actually had the same, if not slightly increased yield. And so they save money by using less nitrogen, and then they continue to have good yield as well. And so because of that, they're saying that the rate of return of using this bacteria treatment across Brazil, basically it reduced the cost by $37 compared to other areas that had, the full nitrogen rate and where this was not applied. And also to focus that there are several different types of biological products on the market too. So that's one thing that I'm trying to have us think about today is just, you have to ask yourself, what's your management goal of using this? Because some of these are formulated such that they're supposed to help increase nitrogen specifically. This specific bacteria strain here that was used in Brazil was the nitrogen fixing strain that they inoculated the corn seed with. There's other nitrogen fixing bacteria that you can use as a foliar application. So also it's a difference of how you apply these products can also change. There's other products that we will also discuss as well that, are there other beneficial macro or micronutrients in the soil that you could apply different bacteria, for example, to help harness. So people are looking at some of these that are supposed to unlock more phosphorus availability for the crop, potassium and sulfur oxidation, as well as another thing that some of these different products are looking at. So also to highlight today that these biological products, we have to ask ourselves with dryland wheat in particular, what's the most limiting factor in our yield? And so I love this, the idea of the barrel of, what nutrient is limiting our yield the most? Because obviously that's the nutrient that we want to try to address the most to help increase our yields. And so unfortunately, dryland wheat, obviously water is often our limiting factor. So that's one reason why I just want to, take these results with a grain of salt, that these were the results that we found this particular last year, where generally precipitation was reduced. And especially we saw that growing season precipitation, the final months when grain fill was happening, we did not get much precipitation at all. So that really, influenced all of our trials, and everybody's yields obviously were decreased because there was less water availability. So that's one question to think about too, is, what's the most limiting factor? Unfortunately for us, it's water. Then you have to think, well, what's the next most limiting factor? Often that's going to be nitrogen for us. So that's why our research was primarily focusing on nitrogen fixing bacteria. And that's what a lot of producers are interested in. But unfortunately, as you'll see with some of these results, that, if water is still the limiting factor, it doesn't matter how much nitrogen we can provide, you still are going to be limited because of that water limitation. Also, what spurred this interest in doing more research on biofertilizers is just obviously in 2021, 2022, we saw the price of nitrogen fertilizers just went through the roof. And so this graph here is showing that you have the price per ton of anhydrous, the average weekly cost of that with month and year. And so these different lines here, we got the dotted gray line is illustrating what the 5-year average is. We have 2021, which started off just fine. Prices were staying about average. And then you can see October 2021, the price just dramatically increased by 2 to 3-fold, stayed high throughout that 2022 growing season. And now in 2023 in red, we can see that price declining. So unfortunately, now the price has decreased. But, I definitely think we need to consider biological products as an alternative to synthetic fertilizer sources when our prices, if they decide to come back up that high, or if availability becomes threatened in the future by different global factors. Other reason that we might want to consider using biofertilizers is this illustration here is showing the cost of our nitrogen fertilizers that we put down. That unfortunately, you put urea or anhydrous in the ground as fertilizer. That nitrification process that happens results in hydrogen ions being released off of that. And so during that process, there's hydrogen ions that get released, and then those go into the soil and result in decreasing our soil pH. So again, soil pH is just a measurement of how many hydrogen ions essentially are in the ground. So the more synthetic fertilizer we put down, the higher the hydrogen concentration gets, and we see our soil pH dramatically declining. In some regions, this pH is getting low enough for wheat that's probably limiting yield. Typically, they say that a pH below 5.5 to 5.2, that's when you're going to start seeing an impact on crop health and crop yield. So this may be a possible tool in the future that you could apply less synthetic fertilizer, apply biological products instead. And so by doing so, you're going to slow down that soil acidification process by essentially just putting less nitrogen down. So one product that we've been exploring here in North Central Oregon is this product called Invita. It's produced by Azotic, which is based in the Dakotas. So they've been producing this product for use on corn and just recently beginning to try and use this product more on wheat. They have done some research trials, but most of the time this product they've tested in primarily the North and South Dakotas, where the growing environment is very different. So you can see here, this is the side of the jug here, the active ingredient, Gluconobacter disotrophics. I won't say that again during this webinar, I promise. But this particular active ingredient, it's basically a nitrogen fixing bacteria that they found in sugarcane, and basically they've been able to isolate it. And so this product works very similar. When we have legume crops, we often want to get those inoculated with a type of bacteria to have that the mycorrhizal fungi basically in there provide nitrogen to those legume crops and fix its own nitrogen. Same idea with this product. The idea is that you would apply this on the wheat. It would create a symbiotic relationship with the wheat plant, and then it would allow the wheat, it would basically fix additional nitrogen for the wheat plant that it would utilize, and then share, some additional resources with this bacteria. This is unique in that they claim that, you apply this product, the bacteria gets inside the stomata, inside the wheat leaf, inside the wheat leaves. And then basically it instead of pulling nitrogen out of the ground, it's supposed to fix nitrogen from the air. So again, often we forget that the majority of the air that we breathe, there's more nitrogen in the atmosphere than there is oxygen. So there's a lot of nitrogen if we're able to harness it in the atmosphere. And so that's what the idea behind this bacteria is, that it would apply that nitrogen from the air essentially and provide that to the wheat plant. So here's just showing an example of one of the wheat trials that they have done in South Dakota, that they're saying untreated versus treated. They're showing that they had supposedly got a 6.8 bushel advantage by applying this product. But again, very different growing environment than here. So that's why we were very curious to see if it would yield similarly here or not. Also, just some more context with this product as well. I mean, if you Google this on the internet, you would be able to find the label for it pretty quickly. But again, this product, they believe that does not overwinter well at all. So essentially you have to wait till the springtime, and you want the wheat getting in about the four leaf to 6 leaf stages. And we'll talk about that some later as well, that, really even at the 6 leaf stage, you're probably getting too late to apply this. So really around 4 leaf is when you'd want to be applying this product in the springtime. Typically you might be able to tank mix this with your spring herbicide application. Just depends on when you're planning that spring herbicide application in your field. Producers have found out that this product does not tank mix nicely with 2,4-D. And so if you're trying to treat broadleaves, you're going to be stuck using potentially more expensive products such as Husky that you could tank mix this in. Or you could also just, consider that, maybe it's worth just an additional cost of applying this on its own. But just letting people know that there is an option of tank mixing this, and it is applied as a foliar spray in the spring. Another product that we tested is Fresh Tracks Universal Microbes. Again, this is a good company. If you go to their website, they've got labels for all their products up there that you can fairly easily see. This product is actually produced somewhat locally in the company Fresh Tracks Ag that's based in the Dalles. Brian Griffith with this company does a lot of research as well in using his product down in California, primarily the Sacramento area, with applications in kind of some of the high valued crops down there, like hazelnuts, some of the different nut crops down there. So it's kind of a different game in California. And so he's interested in seeing how well these products might work in dryland wheat here locally. So that's why he approached me with possibly trying to do some trials to investigate this. So with this particular product, it has several different strains of bacteria that, again, it basically comes, and Vita comes in a jug that's a liquid. This product comes in a powdery form that you can either tank mix in with a sprayer and apply it with liquid. He says their preferred means of applying this is if you could mix it in with basically your starter, your liquid. If you're applying liquid fertilizer on your crop, mix it in with the liquid fertilizer when you're seeding and apply it that way. You can also, like I said, apply it as a foliar spray as well, though. And so that's a particular product from Fresh Tracks. Their Universal Microbes product has several different types of bacteria that are in the genus Bacillus. And so Bacillus is the predominant bacterial genus, basically, where they use a lot of these products from. And so all the different strains of bacteria within this Bacillus genus basically are known that they can do different things with ecological functions in the soil. So the idea here is that, these are not nitrogen fixers, but this is a different set of biofertilizers. Could these bacteria kind of unlock phosphorus and other nutrients that the crop is just struggling to get on its own? So this product actually has 10 different strains of bacillus bacteria in it. They will only tell us four they're actually of the 10. So the other six are kind of keeping for proprietary purposes. But I just want to highlight basically three of these species, just kind of, they're very general bacteria that they don't do anything super fancy, but they're supposed to, increase nutrient efficiency, help with fertilizer efficiency, and so forth. I will highlight the one at the bottom, Bacillus megaterrarium, has been known to increase plant available phosphorus, potassium, and sulfur. And so that's why I think in this case it can fit better into your operations possibly. But I will caution people, you'll see there's a lot of products out there that kind of have some of these general bacillus species that may not necessarily do a whole lot for the soils here or for your crops. So just keep that in mind that if you see products, they have several different strains of bacteria and they don't really like give you an exact thing they're supposed to do. That might be a red flag that maybe that's not a good product to use, because I definitely see a lot of products that allegedly can do all sorts of things for the soil, but they don't really tell you how it's going to actually improve your yield or help with your crop. So keep that in mind. So getting into our actual trials here on the ground. So this last spring, we had a trial looking at fresh tracks and at the product in Vita and spring wheat here at the Sherman County Experiment Station. And so basically we're trying to determine the impact of reducing our synthetic nitrogen fertilizer rates by several different rates, adding these two products separately on that. And then we looked at grain yield, or grain quality, looked at total nitrogen uptake. So we did a lot of tissue sampling as well. And then also looked at a lot of post-harvest soil nutrients to see if anything was changing there. So again, if you're on this call and you're not sure where Morrow is, it really is North Central Oregon here. Sherman County Experiment Station is ran by OSU. We have another trial that we'll discuss in winter wheat that's further away from the station here, but this red circle here is illustrating where our station's at. This is Gordon Ridge here. We also did a on-farm winter wheat trial with a producer as well. But you can see, definitely a region dominated by dryland wheat production here and fairly flat where most of these trials were taking place. All right, some more details on the actual site here. The Sherman Experiment Station in Moore, Oregon's at 1,800 feet elevation, primarily wall silt loams. And we are on definitely, I would say, a 10 to 12 inch precipitation zone. This chart here is showing us our monthly rainfall for the crop year. So starting September 2022 through the end of the crop year there in 2023. And so you can see that for the most part, precipitation was about what it should be for average. And just to illustrate here too, that the black bars are for that last crop year. The gray bars here are for the 30-year average. So you can see several months there. September, the early part of the growing season, we had above average precipitation. However, if you fast forward to June, July, August, you can see we're dramatically below average, and also in May. And so unfortunately, that probably biased the results, but just showing people that we are at 95% of average for the year with rainfall, but the timing of it definitely hurt crop yields and made it harder to look at these products. So typical spring wheat here, we see it at the end of March. We used urea and 1620 starter fertilizer. I will say, keep in mind with these trials, we reduced our fertilizer rates dramatically, but all these trials, we had pretty decent residual amounts of nitrogen as well. So here we had 70 pounds of residual nitrogen already in the soil. And we assumed that, if you're going the higher end of the spectrum, again, you probably want 2 to 2.4 pounds of nitrogen for nitrogen availability per bushel of expected yield. And so we were guessing spring wheat, 55 bushels, which is on the high end for the station here. And so we assumed 2.4 pounds of nitrogen per bushel times 55. That's where we got 130 pounds total nitrogen for our fully recommended nitrogen rate amount. This next slide here is going to illustrate this better. So you can see the percent amount of nitrogen fertilizer recommended that was added. So you can see we had several different fertilizer rates here where we added anywhere from basically just 0, where no starter fertilizer was applied, all the way up to adding basically an additional 60 pounds of nitrogen. And again, that coming out for about 130 pounds of total available nitrogen for the crop to use, all the way down to 70. So I already mentioned with the Fresh Tracks product, ideally you could mix in a liquid starter application. We do not have that set up here at the station. And so basically we went with the foliar route and trying to simulate us having that actually in the drill. I applied it pretty quickly after it was seeded, hoping that that product would get down to where the seeds actually were growing. And then we did two other applications as well. So this is something as a producer you probably would not do. Hopefully you would just apply it as a foliar you would just apply it in your drill, hopefully at planting, and you wouldn't have to do three applications like we did in this particular study. And then Vita was applied, like I said, and Vita is applied as a foliar spray in the springtime. May 10th, the wheat basically was right at 4-leaf, and we follow the label rates there. And also, using a non-ionic surfactant is also important for these products. Use those non-ionic surfactants to really help it stick to the plant is a big help as well. Again, I'll just summarize this quickly that basically, yes, we basically did some wheat tissue sampling. We applied this, and then when the wheat was at the hard dough stage, so basically end of June, early July, we purposely waited for the wheat to be further along the development stage to see, if the nitrogen was any different by using either of these biological fertilizer products. We did standard grain harvesting, soil sampling after harvest as well in August. So you can see this is a picture of what the trials look like. Just looking at the trials, I mean, I don't have that many photos in any of these trials because just looking at the plots, you couldn't see any huge differences. I will say where we did not add any starter fertilizer, we definitely saw areas like this that you can see. This is a zero plot here. You can see there's some increased yellowing in the wheat tissue there that you would expect with kind of reduced fertilizer availability. And I honestly can't remember if this is in a treated or untreated plot, but just showing you that, the fertilizer rate definitely made it apparent where nitrogen was being reduced, but where we applied the product, we did not see as much of a visual difference. Okay, so getting into our actual results here finally. Overall, we found that, statistically, the yield was pretty variable across the different fertilizer rates and where these products was applied. And so that was disappointing that we did not see a big impact on yield directly. I mean, overall, we did see that at the 35 and 20 pounds of nitrogen rates where we added in Vita, that's where we saw the greatest yield. And, it only gave us about a bushel advantage. And you can see, again, the air bars here represent one standard air. And so you can see even within each treatment, there was a lot of variability with yield across the different replicates that were in the experiment. I will say too, the Fresh Tracks product didn't really seem to have much of a spike in any of these, but it was surprising at the zero fertilizer rate. We did have some pretty good yield of 40 bushels for spring wheat. It's pretty decent considering that we use that product. Again, this is another picture of what they look like. I think at this point, the wheat's probably at hard dough stage and getting close to harvest. And again, you can visually see, there was definitely some variability, but overall things look pretty similar regardless of treatment. All right, so talking about grain quality, we did see that protein significantly increased with fertilizer rate, which is not surprising. I think most farmers would tell you that with wheat in particular, where we have more nitrogen available from fertilizer, usually you're going to see increased protein. Our protein, given the drought formation, protein was pretty high in wheat across the county. So relatively speaking, our protein was a little bit higher than we would have liked to see. But was still relatively decent compared to other trials in other areas of the county that were getting protein in the 12-13% range. We did see that in this particular trial, it seemed like we saw a trend of Envita and Fresh Tracks increasing that protein level, but just very slightly, and definitely was not a significant interaction. Test weight, didn't really see much of a change in test weight by using these products or the fertilizer rate. Okay, so this is where we actually did see one good result, was that we found that by applying the Envita in particular, we did see that the wheat tissue, so the actual growing parts of the wheat, had increased nitrogen concentration as a result of applying that product. So this graph here is just showing us again total nitrogen that we found in the wheat tissue with increasing fertilizer rate. And then again, black is a control, gray is in dark gray is Envita, light gray is Fresh Tracks. So you can see here as well. The different red letters indicate that there was a significant difference. And so often we can see that Envita definitely had significantly increased nitrogen in that wheat tissue compared to the other treatments. So it was good to see that the Envita did seem to have a response. We would have loved to see more response with yield, but at least it does seem like it's not just snake oil. It actually is working on increasing that nitrogen in the wheat plant. So total nitrogen uptake, again, and just to explain this a little bit, that total nitrogen, basically the slide I just showed you, that is the actual wheat concentrations that's measured. But we also collect, when we took the wheat samples, we weighed them. And so then you can kind of estimate from that particular plot how much nitrogen is being uptaken on a per acre basis by weighing that dry matter when we took the samples. And so again, here, as you would expect, very similar story. Nitrogen uptake was also significantly increased with Envita over other control treatments. Here, it might help some of you just kind of put it into context that Envita, for example, averaged an additional 6 pounds of nitrogen over the other treatments. And so when you think about, well, how much more additional nitrogen are you getting from applying a product like Envita? We could tell you that, roughly speaking, possibly you're getting an additional, 5 to 6 pounds of more nitrogen into that plant than if you hadn't applied it. So that's a decent boost. Obviously, it's not a huge amount, but that is good to know that we can see a response in the crop as well. So now we're looking at post-harvest soil nutrients. So this is soil nitrate levels with increasing fertilizer rates. Not surprisingly, we did see that the nitrate nitrogen significantly increased as our fertilizer rate increased, which you would expect, right? You put more nitrogen down, you're probably going to see more left behind after harvest. You can see we have some very large error bars as well, particularly at the higher fertilizer rates here. So again, very variable. We were hoping that possibly we would see, if you apply the Envita, is the wheat plant going to pull less nitrogen out of the ground if the Envita can provide more of it from the above air? And so we were hoping that we would see, a response that, well, maybe there would be more residual nitrogen left in the Envita trials after we applied the product. And unfortunately, you can see all the variability here. We definitely did not necessarily see a strong trend that way. You can see there's some, for example, at the middle fertilizer rate here where Envita does seem to stick up just a little bit. But again, these error bars make it so that there's a lot of variability going on and hard to draw any strong conclusions. This is also soil nitrogen, but soil ammonium nitrogen instead. Also increased significantly fertilizer rate as you would expect. And similarly, unfortunately, too much variability to necessarily say, if these products are really changing how much nitrogen is left behind. I will say while we're on this slide too, some people brought up some good points to me that, we're curious that we don't see an increase in soil residual nitrogen where Envita was implied, but possibly a lot of that additional nitrogen that was fixed from the air, once all that residue, so we went through, harvested the crop, that residue there where we implied the Envita, that still has a lot of nitrogen left in it, will slowly break down through the next fallow year. And so, I'm going to do some more soil measurements this next fall to see if once that residue breaks down, would we potentially see an increased amount of residual nitrogen in those Envita plots. So that's an ongoing thing we're looking into, which may have some validity, may not. We'll find out. Like I said at the start, we're hoping maybe if we use these products and reduce that fertilizer rate, maybe we can see an increase in soil pH. We did not see that in this particular trial. I'll also say these soil samples are measuring soil in the top foot. And so if we really wanted to detect changes in pH, we would have to look more closely at probably, the top 3 to 6 inches where that nitrogen is really from fertilizer is really going to change that pH. Similarly with soil sulfur, like the nitrogen, we saw an increased amount left behind with increasing fertilizer rate. And also you can see high variability as well. Phosphorus, also looked at phosphorus amounts. You can see there's possibly some trends in the data, but none of it was significant, and also a lot of variability. Potassium, same story as well. Again, you can see some variability. You can also see that relatively speaking, with fertilizer rate and applying these biofertilizers, we didn't see huge change either way. We did not see much of a change by applying these. So now talking about return on investment, or ROI, for using these products in this trial. So this table here, we have the different treatment, and we have it ranked by the nitrogen fertilizer rate that was applied with. We then ranked these based on the return on investment. And this ROI, we figured out what the income was from yield, and then also with the different protein levels. We looked at different protein premiums for the amount of protein that we had in the wheat. Again, with soft white winter wheat, lower protein is better. Unlike hard wheats, for example, soft white winter wheat, we do not want high protein. So higher protein, you're going to get less money at the elevator because you're going to get docked and get a lower protein premium. So we incorporated that cost into these results as well. So we got our different yield from each trial, the wheat price. We assume 718, that's what it was when these plots were harvested. And we also included the cost as well of how much money did we spend on fertilizer in this plot and how much money did we spend on the product. So that's one thing I haven't mentioned, that the economics of this is, so Fresh Tracks Ag, that product at the time was $12 per acre. And Vita is more around $14 to the acre. So we ranked this trying to figure out what's going to give you the best return on investment with the protein and yield it produces, along with the cost of purchasing it and the fertilizer rate that was used under. So we are surprised, well, in a way not surprised, because obviously if you're not putting down any nitrogen fertilizer, that's going to save you a lot of input costs. And so it's surprising that Fresh Tracks product, we did not see much of a response with the other variables, but it's interesting, it still produced a 40 bushel yield compared to controls that were, the control at 0 was basically 35. And then where we added 10 pounds of nitrogen, the yield was still 40. So it's just essentially by applying Fresh Tracks, we got a 40 bushel yield still. We did not spend $10. We did not spend money on just simply buying even just 10 pounds per acre of nitrogen fertilizer here, causes that control to be more expensive. And so it's surprising, but basically we got another $25 by applying Fresh Tracks and not applying any fertilizer. So again, though, you have to remember this result looks really promising. About why am I spending so much money on fertilizer? You have to remember that we did have 70 pounds of residual nitrogen that was still there for the crop to use. And like I said earlier, it was definitely a drought year too, so that probably helped. So unfortunately, in this case, Vita, though, did not provide a positive return on investment compared to the controls at lower fertilizer rates. So hopefully that makes sense. Vita did not pay for itself. The Fresh Tracks actually did manage to pay for itself and gave us increased revenue over the control at the same fertilizer rate. So again, if you have more questions on that trial, hopefully we can discuss it more at the end. Just want to provide you guys with some more data here as well. So essentially, we did a very similar study that I just summarized in Morrow. We also did a similar study in Pendleton at the OSU experiment station there. Again, there you can see Columbia Basin Agricultural Experiment Station there in the map. Typically, this has a higher rainfall environment than Morrow. So you don't really need to look at this slide. Basically, we looked at the exact same variables as we did as the last one. I do want to give a shout out that this small spring trial was done in collaboration with Don Wysocki and Alan Wertsinging at the station there. And I would not have been able to pull this off if it was not for the assistance of Don to make this happen. So I appreciate their collaboration on this as well. The Pendleton Experiment Station is similar to Morrow, but it's a little bit lower in elevation. I apologize, there's a typo on the slide, but the Pendleton Experiment Station is out right near Pendleton, actually Adams, Oregon. Slightly lower elevation than Morrow. Wall siltloam soils as well, 12 to 14-inch precipitation. And here, Morrow, we were at 95% of annual precip. Pendleton, however, was only at 75%. And you can see here again, these gray bars, especially later part of the growing season, those gray bars are the 30-year average. And you can see our black bars, which represent actual precip for that month during that crop year, were dramatically lower. So we're looking at, reduced precipitation by 2 to 3-fold during the later spring half when we really need it. So I think that definitely influenced our results some as well. So again, very similar experimental design. I just want to highlight here The table is just showing you how we kind of randomized that. But the other table here, the in rate pound per acre. So here we had 5 different nitrogen rates from 0 to 80 pounds of nitrogen. And then basically, a split plot design that we had plots that we applied in Vita and the other half of the plot where it was not applied. Oh, and here I want to highlight then that in Vita, we applied basically the same week that we applied it in Morrow, but since Pendleton is a lower growing site, the wheat was further along. And so we had challenges working with trying to get the Vita here in a timely fashion. It was very cold, if you remember, last spring in the Dakotas, and so they were very hesitant to send out this biological product, worried that it was going to get frozen. I will say that they are working on a dry formulation that they could ship that would not be in liquid form and not be at risk of freezing, but unfortunately they're still getting that developed. And so unfortunately, what I'm trying to say here is that we applied it at the 6-leaf stage when ideally we should have been applying at the 4-leaf. So that was one lesson here, that we applied it late and we did not see the results that we'd hoped for. Again, you can see the trials similar to in Morrow, not a huge difference visually, but you can definitely see, lower fertilizer rates are very evident. And I just want to give a shout out. Christina Haggerty here was a big help harvesting these trials in Pendleton. Here we are in the last plot that we're harvesting there. And great assistance by Alan there as well, and interns that were in Pendleton as well. So just definitely a teamwork collaboration here at OSU. So getting into the results for this particular trial, we found that yield, similar to Morrow, no significant differences. And it seemed like, overall, the 80 pounds of nitrogen rates gave us just slightly higher yield. The best yield that we got was 33 bushels per acre with the control at 80 pounds of nitrogen. Where we backed that fertilizer off down to 40 pounds of nitrogen, we had in Vita that had the second. Vita was basically the second highest yield at the 40 pounds of nitrogen there. So you can see here too, some variability in yield for sure. You can also see that, overall not huge difference here, but definitely with the drought, I was kind of surprised, honestly, that the 80 pounds of nitrogen did better than the lower rates. Just it seemed like that was a lot of nitrogen for the year. Looking at grain quality, protein range from 8.8 to 10.4%, which is actually quite good for soft white wheat. It did increase with fertilizer rate, and that interaction is almost statistically significant, but not quite. An overall trend we saw that was lower within Vita, but again, that was not a significant interaction. So test weight, I know when you look at this graph, looking at test weight for both control and Invita, again, control is black and Invita is gray. Here we actually did see a significant interaction, even though I know this graph makes it look like they were all very similar. We did see that, overall, as you would kind of expect, right? If you have really high nitrogen in the soil and it's really hot, droughty, often those kernels get kind of shriveled up from too much nitrogen later in grain fill. So that's what we think we saw here, that, test weight was lower at the higher fertilizer rates, and it was the highest at the lower fertilizer rates, if that makes sense. So we definitely had better test weight. And the different letters here indicating that there was a significant difference. So basically indicating here that the ones that just have the letter A had significantly higher test weight than the ones that just have the letter B. And so again, unfortunately here, there was a little bit of an interaction going on here, but not a clear trend within Vita either. In Morrow, we saw, that significant response with increased nitrogen in the plant. Unfortunately, in Pendleton, we did not see that. So again, I personally think that we applied it too late in the crop stage to see that response happen. You can see some trends here that total nitrogen probably increased with fertilizer rate, but it was not significant. And we did not see, some of these bars, they do look a little bit higher with Invita than the control, but you can also see there's variability. And so that's why it's not statistically significant. So amount of nitrogen that's actually taken up out of the soil. Again, you can definitely see that higher fertilizer rate, 80 pounds of nitrogen, had a significantly increased nitrogen uptake than those with less fertilizer. So probably just a sign that we had more nitrogen there available from fertilizer, and so there was more of it uptaken in the plant. We did see this non-significant trend, but just to say that we did see that nitrogen uptake was mainly slightly increased with Envita, but the plots in Moro, we said we could maybe get 6 pounds of additional nitrogen in the wheat plant. Here we're just more around 2.76, so not even at 3. Not surprisingly, like I said in Moro, our nitrogen increased significantly with fertilizer rate. Again, these nitrogen levels are those in the soil. You can see there's some variability. That definitely seems like in some of these nitrate nitrogen, you look at the 40-60 fertilizer rates, you can see that Envita had a little bit less residual nitrate nitrogen left in the soil after harvest. Similar story for nitrate ammonium. You can see again the 40-60 fertilizer rates. Seems like there's less nitrogen left there after harvest where Envita was implied. So that was interesting. And obviously the clear trend here as well. Those different letters indicate a significant difference, and we did see that nitrogen increase significantly with fertilizer rate. So here we did see a response of pH that even again, we're sampling that entire top foot. We did see that where we applied no nitrogen fertilizer, our pH was significantly higher. Overall, we saw that pH was slightly lower with Envita. Organic matter we also measure, and that was very variable and did not see any significant increases. Again, here's our scary rate return on investment chart, or ROI. You have our nitrogen fertilizer with the different treatments there. And so unfortunately, the bottom line with this is that applying Envita did not change yield at all. And so where we applied 0 fertilizer, we saved a lot of money on costs from that. And we still had yield. We had a very small yield of 26 bushels per acre. But because of that, not having to pay for any fertilizer, the return on investment was greatest for those controls without nitrogen. And you can see that return on investment for Envita is down on the list, that you were, in terms of economics, you would be better off using a control treatment with anywhere from 0 to 40 pounds of nitrogen rather than applying Envita at no fertilizer. So again, that $14 per acre, if you're not getting that return on investment, probably not worth using it. So real quick now, we will discuss some winter wheat trials. I'll just say in general, winter wheat seemed to do slightly better response with applying Envita on fresh tracks. We think that a lot of this just has to do with, the crop was further along when we applied this on at 4-leaf. Technically they were both at the same crop stage, but, you can kind of think that the winter wheat kind of has some more things already developed by the time we're applying this. And so we're able to see more of a response, I believe, than using this in spring wheat. We did see some responses in spring wheat still, but I just to say our results in this illustrate that there might be a better return on investment with winter wheat possibly. So winter wheat trials near Morrow. First starting off with a producer trial that we did near Gordon Ridge. I appreciate the producer's cooperation. Noah Williams helped us seed this and harvest this with his combine here in this field. So could not do it without his help here. So overall, this field yielded 80 bushels, which a lot of the other surrounding fields are more in this 50 to 60 realm. So I would say the field looked great. So I think one issue there is that the field was so good that we didn't see, a huge advantage of using this. It also might be a sign that maybe you have all your ducks in the row and Envita might not actually be worth the added expense. But so, we did see consistently, we had 4 replicates of where Envita was implied versus control strips right next to it. During this trial, we also looked at fresh tracks. Universal microbes as well were also tested here. Unlike our other trials, our nitrogen rate, fertilizer rate was the same across the whole field. So we did back off our fertilizer rates a little bit. We probably applied about 75% of what would be considered to be the fully recommended rate. And so we clearly saw this trend that every single replicate Envita produced a 1.1 bushel advantage over the control strip next to it. And we also saw that lowered grain protein as well. Fresh Tracks Universal Microbes, we mixed those in with his drill. The Envita, I implied the Envita, same crop stage as everything else. The fresh tracks was different. I'll say that we mixed it in with his grain, in his grain cart. So essentially, he was filling up his drill off of an auger that he had on his truck, and so we basically were just sprinkling in the fresh tracks product into his auger as he was feeding that grain into his drill. And that did seem to do a decent job of mixing it in. That I feel like we applied it the best way that we could, and we didn't see a response, unfortunately. Essentially, the fresh tracks yielded the same as the control treatment. So kind of my big takeaway or so what with these winter wheat trials is that our return on investment, we calculate everything out. We got that 1 bushel advantage, but just with the price of wheat being at 7.18, it was not enough to pay for applying the Envita. And so it's essentially, if the Envita would have cost $1 less to apply, or the price of wheat would have been $1 higher, it would have given us the same return on investment as the control. So that's what I mean here by just below the control by $1.07. So we also had winter wheat trials in Morrow. That for some reason, we did see a really strong response by applying Envita in this trial. And so just real quick too, to summarize, not going into depth on the experimental design because it's very similar to what we did to spring wheat. But in this particular trial, we had places that we applied the full recommended nitrogen rate as our control. And then we had strips next to it where we reduced that fertilizer rate by 15 pounds. So the control, we added 60 pounds of nitrogen. There was just the control. Where we applied the Envita or fresh tracks, we use either a fertilizer rate of 45 pounds of nitrogen or 0 pounds of nitrogen. And unfortunately, we should have had better controls and had added the Envita at 60 pounds of N as well. And so we've got a better trial design for winter wheat in place now. But so essentially, we just want to know, okay, let's say our control treatment is business as usual, full fertilizer rate, no biofertilizer. The other ones, we then reduce that fertilizer rate and apply the product, seeing if it was going to give the same or similar yield as the controls. And so what we found here, as you can see on the slide here, basically where we reduced that fertilizer rate and only applied starter fertilizer, we had an 11 bushel advantage over other compared to other strips next to it where we had applied 60 pounds of nitrogen. So that was very promising. That again, we didn't put down any fertilizer, just starter fertilizer. We greatly reduced that fertilizer expense. And we actually saw an 11 bushel advantage by reducing that fertilizer rate and paying to put these products on. Fresh tracks, again, did not seem to be very promising in this particular trial. It basically yielded the same as the control. We saw trends that protein was lowered with Envita, which again, soft white winter wheat, you would want to see that protein lowered with these products, not increased. Because if it does increase and your protein gets too high, then you're going to get docked at the grain elevator for having protein that's too high. Also here, I will say that treatment where we still applied 45 pounds of nitrogen with Envita, that yielded the same as the control. So that was one thing we're after too here is, the industry standard, often the thought is, you should reduce your nitrogen fertilizer rate so that the crop needs to rely more on the microbes. With the concern being that, if you apply you have over 100 pounds of nitrogen in the soil, the biologicals might just say, hey, you've got enough nitrogen here already, I'm not needed, and they won't work as efficiently. And so we found that we thought, backing off to 45 pounds from 60 would be enough to see a response, and it was not. So we possibly could have added more than just starter fertilizer, and so that's something I wish that we would have done, is it had more gradient of fertilizer that was added in this particular trial, but it does seem that, backing it way down seemed to give us the strongest response here. This picture here, again, I said fresh tracks didn't have much of a response. Unfortunately, the fresh tracks product, we mixed that into the grain drill here. We basically did the same thing in this winter wheat trial as we did with that producer. This product was just mixed into the grain cart during seeding. And we had some mechanical issues. All the other plots look great, but the fresh tracks, we often had, we basically looked like we possibly ran out of seed. And we also had issues with emergence. So a lot of the wheat in those tracks, in these plots, it came up later, just had really late emergence, unfortunately. And so that definitely messed up our results a little bit. So these graphs here kind of help illustrate our experimental design as well that I was trying to describe, that basically we had no just starter fertilizer put down at basically 0 nitrogen. You have where we applied Envita, dark gray, light gray is Fresh Tracks. Our fertilizer rate increased into 45, again, control Envita versus Fresh Tracks, and we had our control at 60 pounds of added nitrogen. And so you can see that this was interesting that where it applied the Envita, it did have more residual nitrogen than where Fresh Tracks was applied. So again, this is soil residual nitrate nitrogen after harvest in August. And it was surprising to see that there was definitely seemed to be more nitrate nitrogen left where Envita was applied versus Fresh Tracks. So, just considering that we didn't add any additional fertilizer, it's kind of surprising that we still had 20 pounds of residual nitrogen left over. Total nitrogen uptake. Again, our experimental design was a little bit different with this trial, so our stats had less statistical power. And so all the stats that we ran didn't really show any significant trends. But just I will say here that obviously you can see, again, looking at total nitrogen uptake here on the right, you can see that Envita definitely had the most amount of nitrogen in that wheat tissue where we applied no nitrogen. So just another interesting trend that we found. Here we did see a response of pH with our winter wheat trial and more out the station. So basically our zero nitrogen treatment, we still had 50 pounds of 1620 that was applied. So that is adding some nitrogen there. I think, 5 to 10 pounds of nitrogen added. But by only applying that amount of nitrogen, you can see that our pH was up above 6 here in the top foot versus definitely lower 5.8, 5.9 where we had applied more nitrogen. So obviously this trend would have been amplified if we had actually sampled the correct depth of the soil, like I'd said earlier. Just the top foot definitely kind of dilutes the acidity layer, but it was just interesting. We still saw this trend. All right, so return on investment on this trial. So again, where we got the 11 bushel increase. Here, this particular trial, you can see some pretty significant trends. So if you look at the green and red colored boxes there, basically you can see Envita under no nitrogen, our return on investment over our control. So this is a little bit different too, that basically we figured out the rate of return on investment for the control and each of these in this ROI, income minus expenses, dollar per acre. We then basically here the 121.13, that's an additional $121 over the control where we applied the 60 pounds of nitrogen. Interestingly, Fresh Tracks, like I said, we had some issues with it, but it still gave us a positive return on investment compared to the control. Also, look in this particular table here. If you go to the far right column there, RI over control at current input costs. And so in that particular column there, basically we didn't use the high fertilizer costs when we seeded in. I purposely looked at what was the cost of fertilizer this last fall. Because obviously if fertilizer prices drop, then the return on investment over reducing that fertilizer rate is going to be less. And so that's why you still see really strong positive returns on investment by using these products, but it's a smaller amount. So I just want to highlight that people understand that connection too. You can see the red ones here again. So basically, like I said, we just backed off that fertilizer rate by 15 pounds. We basically saw the same yield, and we had to pay for these products. So that's a good illustration that it's important to do some math that, okay, so if you reduce your fertilizer rate by 15 to 20 pounds and apply these products, you're saving money by, buying 15 pounds less of fertilizer. However, you're still spending money on these products. And so that's kind of the price breakdown, that these products are costing you $12, $14 an acre. If you're not getting that return on, if you're not getting a yield response, you're still going to be, in the red here, which we were. So, we saved money by applying 15 pounds less of fertilizer, but then we were applying, looking at the $12, $14 an acre by applying the product. And that's why we're in the red there. We're going to skip over this. There's another trial that was done in Wasco County that was not as formally done as the ones I just described to you here. And so I do just want to highlight real quick that they used 3 different nitrogen rates. They basically had 16, 32, and 81 pounds of nitrogen applied. This was looking at just the product Fresh Tracks. And this one they did mix in with the liquid fertilizer. And they only applied on the 16 and 32 pound nitrogen rates. So essentially, unfortunately, they had the highest fertilizer rate at 81 pounds of nitrogen. They did not add the microbes to that particular strip. However, at the 16 and 32 spots, they just added the microbial product. So it makes it difficult too with some of these results that we don't have a clean control, being that, we can't say, oh, we applied the microbes at 16 pounds of nitrogen, and this is how it did compared to where we applied the same rate of fertilizer and did not apply them. And so unfortunately, that makes for a little bit of a messy comparison here. And also something I want to communicate folks that, make sure that if you're considering one of these products, make sure that you've got good research results that the company actually has, where they have a good clean comparison, so they're not comparing it to something else where they've changed the fertilizer rate or something else to kind of make the return on investment look better than it actually is. So I will just say with this particular Fresh Tracks Universal Microbes, in this particular area, Fresh Tracks Ag gave me some funding to do some tissue testing on the wheat. And so unlike the other tests that we did, we were sampling hard dose stage, we sampled the whole plant. This one, I basically was just grabbing flag leaves off the wheat plant and trying to get different nutrient concentrations from that. And so I will just say, this product supposedly increases phosphorus availability. And so when we looked at tissue testing, you can see that basically the 16 and 30 pounds of nitrogen, where again, the Fresh Tracks was applied, we saw that particularly at that 32 pounds of nitrogen rate, it was significantly increased compared to the higher fertilizer rate where Fresh Tracks is not applied. As I said earlier, though, it's difficult to know, is this increase in phosphorus flag leaf concentration? Is it because there's less nitrogen there? There's other interactions that could be going on here. But just want to show this to you as an example that, supposedly if these products can increase phosphorus availability to amount high enough that's going to increase yield, these might be good fit. I think most of the time, though, our nitrogen fixers are going to be what are going to help us the most in this area. This next chart here is soil phosphorus. So just trying to connect the connections that when we did phosphorus sampling after harvest, again, this is August, we saw it, not surprisingly, where you had added 81 pounds of nitrogen along with some other sort of fertilizers in that package as well. They had more phosphorus was left behind than the lower fertilizer rates. So that's what just made it interesting to me, that you would have expected the phosphorus flag leaf concentration would have been higher at that higher fertilizer rate, given that there clearly was more phosphorus available there, possibly looking at the soil. So there could be something going on here where this microbe is basically essentially unlocking phosphorus in the soil that the plant is not able to access it without. More research is needed here. I'm just illustrating what some of these companies are claiming these products might actually help us with. Also with flag leaf sampling that I did in this particular trial, the iron was higher where this product was applied versus the higher fertilizer rate. You can also see that we did zinc flag leaf concentration. That zinc was significantly increased at the middle fertilizer rate where that product had been applied compared to the lower fertilizer product where we used the product and the control where it was not. We're also seeing this with a couple other biofertilizer products on the market. We're seeing that, yes, we get some interesting increased nutrient concentrations in the wheat plants. But, unfortunately, it always comes down to, well, is that impacting our yield or not? So just showing you that, generally don't be surprised some of these products, they do seem to increase your zinc and iron flag leaf concentration in the plant, which can be beneficial, but more is needed to be understood. Just showing this real quickly. Again, this is from the same study. We have our total nitrogen concentration in wheat tissue and total nitrogen uptake. And so you can see here that none of these interactions were statistically significant. And you can just kind of see trends that, adding this bacterial product possibly increased our nitrogen concentration a little bit. But when we look at total nitrogen uptake, it gets diluted out with the amount of plant material that's there. And hopefully people see the distinction that, we sampled up a wheat plant, we figure out how much nitrogen's in it, but then for that particular plot, if there was more biomass that the wheat produced, that higher nitrogen concentration in that sample If we extrapolate that to the whole plot, if there's more biomass, supposedly it pulled more nitrogen out of the soil. So that's why it's a little messy that we can see differences between total nitrogen concentration and nitrogen uptake based on how much plant material is growing there. Well, I want to conclude with one other product that has been showing up here in Oregon. Sound Agriculture has this biological product called Source. Again, one of these classics that has primarily focused on corn in the Midwest. Currently in Oregon, it's only labeled for corn in Oregon. It's not labeled for wheat or barley, but they are in the process of looking for producers that are interested in trialing these products. And so I just want to give a shout out that Jessica here at Sound Ag, she's very interested in working with on-farm trials. And that's why I would encourage people too, that, if you're interested in trying out some of these products, talk to some of these companies and see if they're not willing to provide you free product and basically trial it for free. And, that's a good way to do it. And also just, we need more on-farm trials of these products to work so that both the company and you guys as the farmers can better understand if these are a good fit for our area or if these need to stick in the Midwest with corn primarily. The other image on the screen here is that Jessica did one trial in the area with David Brewer in Wasco County, and just showing that, basically you can see here, this is in soft white winter wheat. You can see that they basically have this field here that you can see highlighted. Essentially, you can see his yield map is what those different colors are. And then you have 4 different polygons where they were comparing it using Source to areas where it was not applied. And so you can see basically, including the cost of using this product, they got a return on investment of $5 to basically $6 per acre, with an increase in yield by about 5%, which doesn't sound like much, but again, just highlighting if it can pay for itself and add a little bit more income per acre, some of these products might work. I'll back up now and explain that Source, the idea here is that you either apply biological products to get the biology in the plant to make it try to find some of these nutrients, or is it the other way around, that there are more nutrients in the soil and we're just not able to access them, nutrients and microbes. So if I can do a better job explaining this, essentially Source is a foliar spray that you apply to the plant, and supposedly it changes biological signaling inside the plant. And so the plant basically through its roots, it starts sending out signals to beneficial microbes to come get close to the plant. So the idea with this is that there are beneficial microbes that can help us reach those nutrients that the crop can't find on its own. And so supposedly this product, it really does kind of sound like a bug in a jug case here, but it sounds like this product can work. Basically, it's a switch that plant sends out signals. It attracts the beneficial microbes, and then those beneficial microbes can then fix more nutrients for the crop to use. And that's where you're seeing this positive return on investment possibly. So again, this is the first trial they've done in the area. I think they did another one up by Friend, I believe, that I've not seen the results from. Very similar story to this, though, that it seemed like it was going to work, but it was not a huge response that they got. So trying to follow up with a so what here, basically explain, like I said earlier, biofertilizers can be effective. We're not seeing any significant increases in yield, but we are seeing, statistically speaking, we're not getting increases in yield, but we are seeing some trends that could possibly give us some positive return on investment, where we apply these products at the right stage and we reduce our fertilizer rate enough. It seemed like some of these products did seem to have a positive return on investment. Again, read the product label. We struggled getting one of those products in a timely fashion. Because of that, we were not able to apply it in a timely fashion. The big question we have too is, in a wetter year with more precipitation happening in the springtime, could you see a better response or possibly a decrease by using this product? And so that's why we've got trials on the ground still for Envita this year, trying to look at that to see if we have a different rainfall pattern, is that going to change what our yield response is going to be? Like I said, too, figuring out our best nitrogen rate. Obviously, lower seem to be better in this particular year. If it's a wetter year, maybe you still want to have 50 pounds of nitrogen you're adding with the product to see a response. Or possibly if you just apply the product and you reduce that fertilizer rate to 0, you're missing out on yield if it's a really wet year, that instead of water being the limiting factor, nitrogen becomes a limiting factor. So you might need nitrogen from synthetic fertilizers and these products both. So I would encourage producers, if you're interested in these products, I think we'll have better results after another year. My hope and plan with the product Invita is that we're going to have 3 years of continuous trial data that we can share with producers. And you can see that, over the variability that we get in 3 years, do these products still pay for themselves, or are these products just going to be another input expense you have to pay for and not see a return on investment? Just real quick to say too, there are a couple other products that are out there. I mentioned Source. There's also a product called Utrisha that we're doing some trials with here as well. Utrisha basically is the same as Invita. It's just a different strain of bacteria that's supposed to be a really strong nitrogen fixer. We're going to try that out and see if that changes anything. We're also doing trials on a product called MycoGold, which is also now called Omnitech. If you Google MycoGold, this stuff will come up. That's a seed inoculant that you add in with the seed when you're seeding. And basically, it's a strong nitrogen fixer along with some micronutrients. So that's another one of those that a couple producers have tried. They unfortunately don't have good control strips for us, so we don't know how good they work. And so we're trying to do some more intensive sampling to better understand if they're a beneficial product to use or not. And again, just want to acknowledge the support I've received from the Oregon Wheat Commission that's allowed these projects to actually happen. I appreciate the interest of my local producers again, and big thanks to Noah Williams for helping assist me with that on-farm trial. The OSU Cereal Grains Program was a huge help, along with interns in Pendleton and in Wasco County as well.